This is Dr. Sridhar, back to you with another video lecture on how to calculate average value, RMS value, form factor, peak factor for sinusoidal wave. Not only sinusoidal wave, we shall continue this with different waveforms by considering square wave, how form factor and peak factor shall be calculated for non-sinusoidal waves also. All these things we are going to discuss in today's video session. So let me take a periodic wave, periodic sinusoidal wave. Now it is having a maximum peak value of V maximum and the negative value is minus V maximum, and it is spread across 2 cycles. I am taking 2 cycles for my convenience. So 0 to pi and pi to 2 pi. Now it makes one complete cycle. Then again from 2 pi to 3 pi, 3 pi to 4 pi. So this is the 4 pi instant. So this is the 3 pi instant. So this is a second wave, second cycle, and this is 0 to 2 pi. This is the one cycle having a time period of t. So this is nothing but the time period t, and second time period is nothing but that is extended from 2 pi to 4 pi. So this is second time period that is represented with 2t. So 2t is nothing but this is a second cycle. Now it has originated from the end of the first cycle and it is extended up to 4 pi. So for my convenience, I have taken 2 cycles waveform. Now if it is required, we can extend this analysis by taking so few more cycles, but only to calculate this average value or RMS value, form factor and peak factor, one cycle is more than sufficient. So I am going to concentrate on first cycle which was extended between 0 to t or 0 to 2 pi. So this is the first cycle, and the waveform is extended between 2 peaks. One is a positive peak is V maximum and negative peak is nothing but it is minus V maximum. So this waveform looks like a sinusoidal form and it is exactly in the sinusoidal fashion. So V of t, because V of t is nothing but it is a instantaneous voltage waveform. So instantaneous voltage and it depends on the time. So this is represented with V of t. So means this voltage V is a function of time t. So V of t, if time t varies, suppose if we are assuming t is equal to 0, then automatically V of t becomes 0. And somewhere at this particular instant, if you could take, then the voltage is nothing but not exactly 0, which is varying, and it depends on time. So that's why this V of t is nothing but this is called as a instantaneous wave, instantaneous representation of the voltage waveform. So V of t is equals, so sinusoidal representation, because already now it is very clear that the waveform is in the sinusoidal fashion, and this is x-axis is nothing but either theta or it is also represented with omega t. That is omega is nothing but the angular velocity, and this theta is nothing but this is known as angular displacement of the wave. And otherwise, in simple cases, suppose if it is a positional control systems or a positional systems, in that one, this is simply it is represented as a time t. So that is the reason now you can represent V maximum, that is the maximum representation. So generally any voltage, if it is instantaneous, that is represented with maximum into in what fashion it was rotated and whatever the x-axis parameter, that is nothing but this is x-axis parameter. So this value is whatever the maximum value, that is a V maximum, and it is varying in the sinusoidal form, and x-axis is nothing but that is omega t, or this is also represented as V maximum into sin theta. So that is the representation of this input waveform. So V of t is equal to V maximum into sin of omega t or V maximum into sin theta. So this is like this we are developing the mathematical equivalent of this graphical representation of the waveform. Now this is shown in the graphical form. So this is a waveform representation of this voltage. That voltage is nothing but the instantaneous voltage V of t. So this voltage, this graphical representation of this particular voltage, we have to convert into a mathematical form, because this average value, now the formula for this average value is nothing but a function's average is equal to 1 by t. T is nothing but it is a time period, and integration over 0 to time period into f of t into dt. This f of t is nothing but that is the instantaneous equation or instantaneous value of the voltage waveform over time t, and what are the distinct limits of that voltage waveform. The distinct limits are nothing but 0 and t. So you have to integrate this instantaneous function between two limits. So that is 0 and t is nothing but the lower limit and upper limit. So this is the expression. So this is the equation we are going to use to calculate this average value. So in this one, the main thing is time. You can easily identify whatever the time t by seeing this waveform, right? You can get this value from the waveform. And 0 to t is nothing but the lower limit and upper limits. We can easily find out the limital values. And whatever the f of t is nothing but that is the instantaneous value of this mathematical equation. So whatever the instantaneous value, so instantaneous value already we have represented, because this instantaneous value must and should be represented in the mathematical equation. So v of t is equal v max into sin omega t or v max into sin theta. So with which expression we are convenient, you can take that expression directly in place of v of t. So whatever the time period now, time period is 0 to pi and then again pi to 2 pi. So this is nothing but it is a completely one time period. But whenever we are calculating this average value, in this average value only we have to take half of the time period only. I mean to say that is 0 to this pi only. Because if you are taking this complete cycle, so this positive half cycle and negative half cycle, in terms of the area, these are equal and same. Only the thing is positive half cycle and this it is negative half cycle. Now if you are calculating the average value from 0 to this capital T, then it becomes 0. So that's why whenever we are making an attempt to calculate this average value, generally we are going to compute this by taking half of the cycle. So in this one, the time period is nothing but t is equal to pi only. Actually, this time period is equal to t is equal to 2 pi from this waveform. But whenever we are calculating this average value, only half of the segment only we are going to consider. So this time period t is equal to pi. Then v average, this function f is nothing but the v average is equal to 1 by pi integration over lower limit is 0, upper limit is pi, v max into sin of theta into d theta. So after getting this, now you can integrate this. V average is equal to 1 by pi and this is v maximum into sin theta. Integration is nothing but the minus cos theta and limits are nothing but the 0 to pi. Just you substitute the limit values in this expression, then you can directly get the value of average, that is nothing but v average is equal to 1 by pi integration over 0 to pi v maximum sin theta into d theta. This is the expression already we have represented for the average value. So this is 1 by pi into v maximum, straight away I am writing outside this bracket, and sin theta is nothing but that integration of the sin theta is nothing but minus cos theta. So limits are 0 and pi. Just you substitute here. So this is v maximum minus v maximum by pi into cos theta first, upper limit cos pi minus lower limit cos 0. So this is minus v maximum by pi into cos pi is nothing but minus 1 and cos 0 is nothing but again minus 1. So this is minus v maximum by pi into minus 2. So this is directly average value is 2v maximum by pi. So like this, we are going to calculate the average value of that voltage waveform which was represented in the sinusoidal fashion. So this is the one expression. Similarly, let me calculate that RMS value also. Now here, coming to this is the second thing is nothing but, now in this section, we are going to compute RMS value. So the formula for this RMS is FRMS, or this function RMS is equal, now square root of 1 by t integration of 0 to t f of t whole square into dt. F of t whole square is nothing but again it is a instantaneous function. Already we know the value for this v of t or f of t. Just now in this case, time period is nothing but the t is equal to 2 pi. So VRMS is equal square root of 1 by 2 pi integration of 0 to 2 pi v max into sin theta whole square into d theta. So in this one, now here this is we had to calculate square root of 1 by 2 pi integration over 0 to 2 pi v maximum square into sin square theta, that you had to write 1 minus cos 2 theta into d theta. Then after getting this, now you start integrating 0 to 2 pi is how much? 0 to 2 pi over 1 minus cos 2 theta over d theta. Now we have to compute this value. This becomes your VRMS. Now that's the same thing here. Just substitute all the values and we can directly get VRMS is nothing but the Vmax into root 2. These two expressions are very, very important, and these expressions are used to compute average value and RMS value for a purely sinusoidal waveform. Now after calculating this average and RMS value, let me calculate whatever the form factor. Now what is expression for form factor? Form factor is nothing but that is the ratio between RMS to average value. Now whatever the RMS value already we have calculated, that is V maximum by root 2, and average value is nothing but that is 2 V maximum by pi. Just to substitute there, now straight away we are going to get form factor is nothing but this is 1.11. This form factor is very, very important, and this will be helpful for us to know the RMS value by knowing the average value. This form factor is highly useful while computing the EMF equation in the transformer also. So that's why now what is the procedure to calculate the form factor? Means simply just to take the ratio between RMS value to the average value. Now we are directly going to get whatever the form factor of the given waveform. Now last one is what is the peak factor? Peak factor is nothing but the peak value, which is nothing but the peak value or maximum value to the RMS value. Now whatever the peak value, now peak value is nothing but V maximum. So this is the ratio between is nothing but the V maximum divided by the RMS. RMS is nothing but this is V maximum by root 2. So straight away, so this value is V maximum into root 2 by V max. So V max gets cancelled. So this value is nothing but the root 2, that is 1.414. So peak factor is nothing but that value is 1.414. So these are the different quantities one should know if any given signal or waveform is given to us. So here we have to remember 4 important things. Whatever the average value, that average value is 2 V maximum by pi, and whatever the RMS value, so this RMS value is V maximum by root 2, and next one is whatever the form factor, that is 1.11, and whatever the peak factor, that is nothing but root 2, that is 1.414. So these are the various values of given sinusoidal waveform. Similarly, let us extend the same discussion by taking another waveform, that is nothing but the off sinusoidal waveform. So this is sometimes it is also called as this is the output of off-wave rectifier. So average value, RMS value, form factor and peak factor for off sinusoidal waveform. This off sinusoidal waveform we are going to get from the off-wave rectifier. So if the waveform is like this, then how we are going to calculate average value, RMS value, peak factor and form factor. So same that mathematical expression is V of t is equal to V max into sin theta or V max into sin of omega t. This is a mandatory thing. First of all, what is the waveform they have given to us? Now try to develop the simple mathematical equation which will describes the given waveform. This is the first and foremost thing. Now one should remember this, whatever the waveform they are going to give. Now with the known fundamental equations or with the fundamentals available from the electrical engineering or mathematical fields, let us describe with a suitable mathematical expression which describes well about the given waveform. So that is nothing but V of t is equal to V max into sin omega t, or this is V max into sin theta. Now this hopefully describes well about the waveform which is nothing but the off-wave rectifier output wave. Now already we know the formula for average value and RMS value. Only here it differs whatever the time period. Time period varies from signal to signal. So time period t is equal to it is 2 pi, and t is equal to 2 pi for both the cases. Why? Because in the previous case it is a completely sinusoidal waveform where we observed negative cycle also. This area of positive and negative is same. So that's why average value while calculating the average value we have taken only half of the time period only for completely sinusoidal waveform. But here in this case, now it is a positive and negative cycle is nothing but it is 0. So this is from 0 to pi, then again from pi to 2 pi. This is the one waveform. Again this one is active, then again from another interval, that is, this is 2 pi, this is the 3 pi instant, and this is the 4 pi instant. So this segment 0 to pi and pi to 2 pi, this whole bit, now from here to here, this is completely repeated. So that's when this is periodically it is repeating. So that is the reason the time period is nothing but that is 0 to 2 pi. This is the time period stretch. Now from here to here, this is the time period of the given waveform. Now that is the reason we have represented that time period t is equal to 2 pi. Now here, of course, from pi to 2 pi, so in this region there is no signal. So that is the reason we can write this v of t is equal to 0 between pi to 2 pi intervals. So whatever the average here, v average is equal to 1 by 2 pi. This is the total time period. And the limits are, of course, we have to take from 0 to 2 pi, but this can be divided as 0 to pi plus pi to 2 pi. Of course, from pi to 2 pi, whatever the function value is 0. So you need not take pi to 2 pi interval. Of course, if you could take it as also, the function you have to write 0 into dt. So that's why I am ignoring the second one. Only I am taking 0 to pi. So that's why 1 by 2 pi integration of 0 to pi. And whatever the function here, function is nothing but the v max into sine theta. So v max into sine theta into d theta. Then the next procedure is, again, you can write v max outside the bracket, v maximum by 2 pi, and sine theta is equal, and which is nothing but minus cos theta. Limits are 0 to pi. Just you substitute the limital values, cos of pi and minus cos 0. Then you will get 2 and 2 v maximum by 2 pi. So this is nothing but v maximum by pi. So already we have written here. The next one, similarly for RMS value also, VRMS is nothing but integration over 1 by 2 pi, 0 to pi, v max into sine theta whole square into d theta. And same concept, pi to 2 pi also, in this one also we are ignoring, because from pi to 2 pi in the given waveform, there is no signal is available. So the strength of the signal is nothing but the 0. So that is the reason from pi to 2 pi, we can write it as a 0. So integration over 1 by 2 pi, integration of 0 to pi, v max into sine theta whole square into d theta. Now same, just simplify this by taking the integration, and after that just substitute lower limit and upper limit of the integrator. Now we are going to get VRMS is equal to v maximum by 2. Same form factor we can calculate, and peak factor also, this is 2 and this is 1.57. So you can observe the difference if the waveform is full sinusoidal or if the waveform is half sinusoidal. If the waveform is full sinusoidal, the form factor is just, it was 1.11, and this is nothing but it was root 2. So that is the difference. So all these parameters, that average value, RMS value, form factor and peak factor, varies from signal to signal. And you can take one more example, that is average value, RMS value, form factor and peak factor for full sinusoidal waveform. So here, this is the output of full wave rectifier. In the previous case, we have discussed about a signal, that is the waveform, which was the output from a half wave rectifier, and this is nothing but it is a full wave rectifier. So the waveform is nothing but 0 to pi, then again pi to 2 pi, 2 pi to 3 pi, and 3 pi to 4 pi. This peak, this first one, the waveform which was existing between 0 to pi, this one is repeatedly occurring now regularly. So whatever the periodicity of this waveform, periodicity is nothing but the time period is nothing but only 0 to pi. So this is nothing but it is periodically occurring, 0 to pi, right? Then again pi to 2 pi, it is same. 2 pi to 3 pi, it is same. 3 pi to 4 pi is also, it is same. So whatever the time period of the waveform, so it is repeatedly occurring with a stretch of pi. So this time period t is equal, it is pi. So whatever the average value, so 1 by pi, integration over 0 to pi, v max into sine theta d theta. So v maximum by pi into minus cos theta, just now you can see 2v maximum by pi. Similarly, RMS value also, now just 1 by pi, integration of 0 to pi, v max into sine theta whole square into d theta. Here, this whole square is nothing but that is for the whole function. This is very, very important. Generally, people will ignore this v maximum while taking the squaring, but you have to take this square for the whole function. That whole function is nothing but it is the combination of the maximum value and in what fashion the signal is moving. So, v max into sine theta whole square into d theta. This is one important thing. Don't ignore this, because this f of t whole square. So whole square means it is a combination of V maximum into sine theta and then whole square. This is an important thing you should not forget. Then again, form factor, and this is nothing but the peak factor. So this is average and RMS value and various factors of full sinusoidal wave. Similarly, we can extend for square wave also. Now here also see the beauty of this waveform. Now here this is the positive half cycle, this is the negative half cycle. Now while you are calculating the average value, now only you have to consider from 0 to pi. And this is the triangular wave. Now here this is 0 to pi positive and again pi to 2 pi it is negative. So based on this also, first the thing is here the major difference between the previous one, this one, the whatever the sinusoidal waveform, is it a sinusoidal? No. So here V of t you have to write whatever the mathematical equation of this shape. This mathematical equation is nothing but from, so the equation I am writing here, V of t at t is equal to 0, this is 0. At t is equal to 0, that voltage is 0. Now again 0 is less than t is less than pi. Now in that cases, now it is having a constant magnitude, having a magnitude of V maximum. Then again at t is equal to pi, what it is happening? This is again it is going back to 0. Now if you are taking this interval, so this segment 0 to pi, now we don't know exactly whether it is in the sinusoidal waveform. No, it is not in the sinusoidal waveform. In such cases, better the first and foremost thing while you are calculating the RMS values or average values, form factor and peak factor for a given waveform, keenly observe the given waveform, and after observing this waveform, better represent or replace this waveform with a suitable mathematical equation. How can we develop the mathematical equation from the given waveform? So that is the thing here. V of t is equal to 0 because at t is equal to 0, the signal strength is nothing but it is 0. And so from 0 to pi, so in this region, so the voltage is nothing but this is having a constant magnitude. So 0 is less than, t is less than pi. So this magnitude is V maximum. Then again at t is equal to pi is equal to 0. So whatever the voltage here, instantaneous waveform. So instantaneous voltage is nothing but it is varying from 0 to, so t is equal to 0 to pi. Between 0 to pi, now whatever the value of this voltage, so that voltage is nothing but the V of t is equal, this is V max. So this is the mathematical equation of given square wave. So of course it is simple, but let us apply the same concept if it is a triangular one. So triangular one from 0 to this one, it might be pi by 2 value, then again pi by 2 to, so from this instant to pi, again it is decreasing. So it is increasing and it is decreasing. So for this total thing, we have to write the mathematical equation. So from 0 to pi by 2, from t is equal to 0 to pi by 2, means in this time period, if we are traveling from t is equal to 0 to pi by 2, whatever the waveform, now clearly if you are representing separately, now here this is t is equal to 0, this is pi by 2, and let me assume this is pi. Now whenever you are traveling from t is equal to 0 onwards, now in this moment, then whatever the voltage, how it is varying? So linearly it is varying. So linearly increasing. So which is passing through the origin. Now you know the slope of this line. Now the slope of this line is nothing but that x-axis is nothing but mx. The formula is nothing but m into x. The slope and this x is nothing but the pi by 2. Similarly, from pi by 2 onwards pi. So if you are decreasing in this particular direction, it is having a negative slope. Now from pi by 2 to pi. So whatever the change in, so how can we find out the line equation? Now we have so many mathematical methods to determine. Suppose now for the first interval if you could take, so this origin is nothing but 0 is time, and whatever the x and y axis, it is 0 comma 0. And for the second point, suppose let me take this is O and this is point A. What are the ordinates of point A? That ordinates of x point is nothing but x pi by 2, and y axis y point is nothing but y coordinate is, this is V max. So by knowing the 2 points, you can easily find out the line equation. Similarly, you can apply the same concept for this line second also, that is which was extended between A to B. So whatever the line equation AB and whatever the line equation of OA. So if you are combining this and whatever the V of t, so that is nothing but the 2 V maximum by pi, and it is a function of time t. So this is very, very important. 2v maximum by pi into t. This 2v maximum pi is nothing but that this is the slope. V maximum by pi by 2 into time t. So v maximum by pi by 2. Now you can simplify this, that is 2v maximum by pi into time t. So, and after this, what about the repeatancy? Now you can take t is equal to pi by 2 or t is equal to pi also, no problem. Now this is the method to calculate the various values of trigonometric triangular wave. So you can extend or you can have a complete practice over calculating for average, RMS, form factor and peak factor for different waveforms as described here. Thank you very much. Thank you for watching this video. I hope these examples has given a good idea to calculate average value, RMS value, form factor and peak factor. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.